Hey, welcome to the second feedback video. This week we have received 7 submissions for assignment 2, consisting of nice nulled pictures, videos and of course the hurdles involved while dismantling your case product. We even saw some participants work in assignment 3 and 4. Very cool to see. So we will run through some of your contributions and discuss pointers and key takeaways. I will also discuss work from your colleagues who also worked on assignment 3 and give some pointers on how to do this in a correct way. Next, I will discuss the main takeaways from the dismantling process. And finally, I will tell you a little bit more about the upcoming assignments. So let's start with the Stokke Trip Trap chair from Sarah. This chair is made to be assembled by the user themselves, so it must be easy to dismantle after first use or for repair. So this product is for the first parts very easy and quickly to disassemble in less than 10 minutes. But however, the last 4 floor protectors also took 10 minutes to take apart. Sarah eventually asked the second person, her boyfriend, to help her out. These parts required several tools to try and get these fixed parts separated. These parts would be called the hotspots in your product. And it's great to see your persistence to entirely disassemble this product. Our compliments for your efforts. So the next case study is that of Fabian. He dismantled a handheld mixer from 1981, and the case surrounding the electronics was easy to dismantle. But Fabian faced some struggles when he got closer to the inside. The ease of access in the first steps is very important for repair. If the product is found difficult to open up, this might be found daunting for the repairer, which results in a lower chance of the product actually being repaired. Knowing how to open up a product is therefore very important, and the availability of documentation on how to do this is an important part of repairability scoring, as for instance the French Repairability Index, but also in the upcoming index proposed by the European Commission. Fabian uses a screwdriver and pliers to dismantle the mixer, but when he reaches the electronics, he tries to separate it with another pair of screwdrivers and some manual force. However, he does not make any progress while doing this because some of the parts are soldered together. He ends the video with the conclusion that in this case, it should be really easy to separate parts if you're able to solder. As not everybody at home is able to do this, this makes it difficult to gently dismantle this product. A solution for this could be the use of old-fashioned wire connectors as seen in Ewald's dismantling video, where he dismantled a coffee grinder. Ewald could dismantle most of the electronics parts because there was very little soldering involved. Wire connectors allow for a gentle dismantle of electronic parts, as you only need a screwdriver to separate the wires. Nowadays we use more advanced and clip-on wire connectors, which are also RoHS and CE certified and which are safer than the old-fashioned version you just saw in the previous slide. So comparing this old mixer from Fabian with the sealing mount of Fieke, which is on the right side, we notice that the mixer has standardized screws, which made it possible to only use one type of screwdriver to unscrew all screws. Fieke's rotatable sealing mount for TV sets required 7 unique tools to dismantle all parts. And you even used a wrench to unscrew some of the screws, which is very uncommon to do. Did you need a specialized tool for these screws? So please put that in the notations in the notes in your hotspot mapping spreadsheet. Nowadays, a lot of products are designed in such a way to make disassembly more difficult for the consumer, where specialized tools are sometimes used to make this process more daunting for them. Let's focus on Fieke's dismantling of a rotatable ceiling TV mount, which she dismantled to its bare bones. She already made a hotspot and disassembly map of the products, which you can see on the Miro board online, and which is really nice to see. In many cases, there are some issues with filling in hotspot mapping, so let's focus on a common mistake made. Here we see Vike's hotspot mapping, which shows the hotspot activities or the hotspot parts in the yellow columns. You can also spot the difference between the grayed out cells and non-grayed out cells. The grayed out parts concern the subassembly, which is to be dismantled further in the later stage. But I notice in the hotspot that the defined subassemblies are not dismantled any further in the spreadsheet. For instance, part SEPUC1045 returns in a later stage, but PFB3406 does not. If you're not going to dismantle a subassembly any further, please define them as part and choose no in the subassembly column. They are the so-called end parts as described in the manual. So next week, check out the manual to see if you made any small mistakes in the hotspot mapping or disassembly mapping. It's very common, so don't worry. Please also bear in mind that you do not populate the grayed out cells with data, like in this example, where the maintenance, functionality and the weight cells are filled in. Please leave these empty. They will be taken into account when you enter the parts dismantled from this subassembly at a later stage. Currently, they are taken into account double, and that's not what we want. Thanks, Sandra, for sharing your system to collect pieces of a turning machine, or in itself a latte, I think. I found your case study a very good example of a product or part of a product where maintenance and repair is usually taken into account during the design process. This part is part of the latte, which is subject to high forces, wear and breaking of parts. Therefore, to extend the life of the product or this part or this subassembly, it should be easy to dismantle, clean and maintain. Still, there are some optimizations to make to improve the ease of accessibility even more. The number of bolts and screws is very high, especially in the part where it takes a long while to reach the transparent plate underneath. I'm looking forward to your hotspot and disassembly map to find out possible circular improvements you could make. PS, you can address multiple unscrew activities in the hotspot mapping as a one activity or as multiple single activities. For instance, over here, you see the example made by, like this example from Ewald and his coffee grinder. But you can also group activities, like unscrewing multiple screws in one single line, like in this example, where Vike grouped the unscrewing of the two screws in one line. Make sure that you note down the total time to dismantle and the total weight of the two screws in the cell and not that of the single screw. So there are two ways to do so. So please bear that in mind, and you can make your own choice in that. While dismantling products, you always learn about good and bad design, struggles at the end of first life and how components are connected. By actively dismantling, you will become a more practical designer, improving yourself with every disassembly. When you do this with an eye for issues involved during the dismantling, each time you will get more professional and become a circular practitioner. So let's see what's coming up for next week's. For now, you have finished assignment 1, the value capture example, and assignment 2, the disassembly of the case product and the shooting of the video. In the upcoming assignment, you will fill in the disassembly map, which you can download the hotspot mapping spreadsheet from the Prophet website. As a tip for everyone for assignment 3, please also jot down your hurdles in the notes section of the hotspot mapping spreadsheet. Hotspot mapping is limited to 100 parts, so if you need more, please let us know and we'll send you a version with more. To fill in the form correctly, you need all parts disconnected and a weighing scale. In most cases, a general kitchen scale will do, but if you have a smaller object, a more precise scale has to be in use. So just have a look at your scales, and 0.1 grams resolution would be excellent for this job. Assignment 4 consists of producing the disassembly tree. You can make it very fancy, but a sketching with sticky notes is a good starting point where you can make changes in the layout very easily. More about it you can find in the hotspot mapping user guide. So find that and read it through on the Profed website. Your final deliverable, assignment 5, consists of assignment 2 to 4 grouped together with an interpretation of the results. This deliverable is part of your certificate, so don't forget to upload it before November 21 at 11 a.m. Central European Time. More about it you can find in the Hotspot Mapping User Guide. So to wrap this feedback up, I wish you good luck with the upcoming assignments 3 to 5, and we advise you to try and stick to the deadline. If you're late, we cannot give feedback on your deliverable, but you will always learn from other one's mistakes. So don't forget to download the Hotspot Mapping User Guide, in which all attributes are explained and tips are given to help you through the process smoothly. If you already done it, please read it through and see if you made some minor mistakes. It also contains handy redesign strategies after you have finished the hotspot and disassembly mapping, which you can use to make improvements of the current design.